Okay, so we're going to continue working with the DAC here on the ESP32. And so the next step is we're going to basically use it to generate some tones. And so we did that last time, but it made a pretty ugly sound. It was a super low frequency. It sounded kind of funky. And the reason is because when we were doing this, we were feeding into that DAC. So we were feeding this DAC one note at a time. And we got rid of all these delays and these print statements to try to make it as fast as possible. But the issue was that we were just basically this is really slow and we have no control over the frequency. And so if we want to play an actual tone that matches a frequency, there's some really complicated stuff that needs to be done underneath the surface to allow us to do that. Basically, we have to feed the data into the DAC at the correct sample rate, and then for that sample rate, we have to then adjust the number of samples as well. And then with those things combined, we can then generate the frequency we want. And so there's going to be some calculations going on underneath as well to make sure we're using basically you have to adjust some like configurations probably on the DAC itself in order to have it feed at that data in the right at the right rates. But essentially we're going to use some libraries that will do all this work for us, and they use something called DMA, or direct memory access. And so this process here where every time through the loop we write a value to the DAC, this is really slow from the, I mean, it's fast, right? Faster than you could observe, but it's slow on the sense that when you are trying to make a signal, like an audio signal that has a relatively high frequency, and these aren't even necessarily relatively high frequencies, but they're high for us. You know, we're talking in the 200 to 1000 hertz range. If we want to generate that signal, we can't just manually feed in those values because it's too slow. We don't have control over the frequency, and you just end up with a kind of a nasty sound like we got before. Okay, and so we need to use libraries that are going to use the DAC to basically do that work for us. And so we're going to basically, over the next two lessons, we're going to look at a couple different libraries. The first one is a little bit simpler, and it's just going to directly feed a frequency. Okay, and so we'll start with that now. And what we're going to do is we're going to go to our platform IO configuration, and we're going to go to libraries, and we're going to find the DAC ESP32 library. Okay, this one right here. And we're going to add it to this project. And so the one that we're using is this one. So we've added it to our project. Click add. And basically, if you want to add it, you can also just basically copy this line here into the library, into the platform io.ini. And so here we have that platform io.ini. We can manually add this here instead of having to go in there and select it. The other thing we'll do, we have the monitor speed set here to 115/200. If you don't have that, you're going to set that, at least if you use platform IO. And the other thing we'll do is we're going to say monitor echo, and we're going to set this to yes. Okay, and we'll show what that does later. Okay, so coming here, let's go ahead and write out our code. Let's include our library. So DAC ESP32, and so we're going to start by making an instance of this library, the DAC object. We're going to attach it to our GPIO 25. Okay, and then if you wanted to learn more about this library, you can right click here on that DAC ESP32 class and go to the definition, and then you can kind of see what's going on all underneath. Or in our platform IO here, you can go to .pio, libdeps, and then here you've got the actual code for it, and then here you can also find some examples. And so this is basically and just an example of outputting a simple cosine wave, and this is what we're basing ours off of, this one right here. Okay, so coming back to here though, so we've got our serial.begin, And what we're going to do is we're going to basically output notes by typing in numbers. So we're going to make our frequencies they want to output. So we're going to make an array called scale frequencies, okay? And we're going to put into it the following frequencies. So 261, 294, 330. So we're just trying to make a C major scale here. 330, 349, 440, 494, and 523. And so this will be, let's see, 1, 2, 3, 4, 5, 6, 7. Did I skip one? 1, 2, 3, 4, 5, 6, 7. I did skip one. Let's see, I'm missing. Got 349 missing. 392. 392. Okay, so that's our scale. Those are our frequencies that we're going to play. If you want to change the scale and look up your own frequencies, you can search musical note frequencies. There's a chart right here that's really helpful. So ours we have starting at C5. And so, actually we don't. Starting at C4, I think, right? Yeah, 261 and going all the way up to C5, which is 523. And so C, D, E, F, G, A, B, C for our scale. Okay, and so you can do this. You can do your own scale. You can come up with your own notes for it. And let's put this back up here. Okay, so we've got our frequencies. We've got our serial.begin 115200 here. Okay, and now we're going to just press that. So serial.print ln ready to play scale. Type a number between 0 to 7 to play note. Okay, and so we're going to basically type these using the keyboard, and so we're going to turn on our keyboard into a little piano here. Okay, so we've got that. Now in our loop, what we're going to do is basically we're going to read that serial input, and so we're going to say if serial.available, and if that's greater than 0, and then we're going to read in the current note. So we're going to say note is equal to serial.read, and that's going to read the current value, and we're going to subtract away the character 0. Okay, and what's going on here is when we read this in, it's going to read in an ASCII character. For example, the character 1. Okay, so the character or string value of 1 has the decimal value of 49. Okay, 0 has the decimal value of 48, and so if we subtract away 48 from this, so 49 minus 48, we end up right here with 1, and that's the integer 1. And so to turn these into an integer, we're basically subtracting away the value of that of 0 to turn it into a number. And so there's functions that will do this for you, but that's kind of like a simple cheat way of doing it as well. Okay, so we're going to read that in, and then based on the number that we get, we're going to play a sound. And so we're going to say if note is less or greater than or equal to 0, so make sure it's a valid input, or and, right? Note is less equal 7. So if you want to add notes, you'll need to change these to match that. Okay, and we'll say else serial.print ln invalid note. Okay, we'll print it here so we know which one we're talking about. And we'll skip a line here. Okay, and so now we're going to, based on that note, we're going to play a sound. And so we're going to say int frequency is equal to scale frequencies, and we'll index it with that value. So 0 will play 261, 7 will play 523. There's a typo here, so check the typo. Okay, and now we need to enable the DAC. So DAC 1 dot enable, and then we're going to say DAC 1 dot output cosine wave, and we'll put in our frequency. Okay, and then we'll play it for, say, half seconds. So we'll say play 500 DAC 1 dot disable. So we'll turn it off. So we'll play that note for like a half second, and then we'll turn it back off. Okay, and now we've got it. This will do it. So you want to run this by pressing the arrow here. And it's going to send it over, and we should be all good. So if you've got it all wired up correct, you've got your amplifier hooked up. Give this a second to upload, and then we should be able to type in our values here. Okay, so we're uploading it. We're going to click right here, the little plug, to open up our serial monitor. We get our message, ready to play scale. Type a number between 0 and 7 to play a note. So we're going to write 0, 1, 2. There you go. So now we can play our notes. You can play a scale there. You can modify it to change your own scale. Have your own notes. You could add more notes, right? So we only have here. I mean, you have all the characters on the keyboard. If you want to use additional characters, you can do that. You'll have to figure out how to map those into values here. One thing we could do is, I think we have some alternatives here instead of read. I think there's a parse int function that we could use to add more numbers. But that's we'll look on that in the next part. But yeah, so now we've basically made a scale. So we've got our DAC. You can adjust the volume of it here by turning the potentiometer on the amplifier. So we'll turn the sound way up. Oh, I broke mine. So be careful turning that thing because it'll break. Oh, and now it doesn't even work. So I broke my amplifier here. Let's see. It still kind of works. Okay, so anyways, be careful turning this little dial on there, the potentiometer, because it will break. I just broke mine, and then it doesn't work anymore. Or at least I must have turned the volume off. I don't know. But on the next part, we'll look at another library that will actually give us some control over the tones, and so it will actually play sounds that sound like instruments by doing some blending of waves. And then from there, we'll go ahead and turn it into like a touchpad piano.